we can use a matrix to solve a system of equations. If you think about it, think about the elimination method of a system of equations, really all the actions in the coefficients. We multiply the coefficients of one equation by a number. We add the two equations together, which involves combining like terms using the coefficients. So it's really all about the numbers. That's pretty much what a matrix is. It's all about the numbers. So first of all, I have to turn my system of equations into a matrix. The way that's going to work is the matrix will have one row for each equation. So in my 2 by 2 system here, I'll have 2 rows, one for each equation, and then it'll have a column for each variable along with a column for the constants. So I'll need a column for the x's, column for the y's, column for the constants, which means I'm going to need 2 rows and 3 columns. So my matrix will look like this. We call this an augmented matrix. It's 2 equations, 2 variables, plus an extra row for the constant. Augment means make it a little bigger, add in that extra column for the constants. Now I'm going to fill in. First column is for the x's. Top row is for the first equation. So I have 3x, then I have negative 2y. In the second equation, I have 1x and negative 1y. And my constants, 4 for the top equation and 3 for the bottom one. There's my augmented matrix. The goal when we're using any matrix for a system of equations is to get zeros below the main diagonal. Well, where's the main diagonal? It starts with the 1, 1 entry, so it starts at the 3 up here and goes diagonally like that. Zeros below the main diagonal. Well, there's only one thing below the main diagonal, so I want to turn that 1 into a 0. Can't do it by waving a magic wand. Poof, you're a 0. Doesn't work that way. But what we do have is row operations. And these are going to look a whole lot like the things that you would do if you were doing elimination. There are 3 of them. We can swap 2 rows, because if I change the order of the equations, it doesn't change the outcome at all. I can multiply a row by a constant, just like we might have to do during elimination. And I can add together 2 rows, or add together multiples of 2 rows, just like in elimination. Eventually, we add the 2 equations together. Well, let's see. Here's my augmented matrix. I'm going to cheat and copy and paste, because even with all the arrows up and down, it's still faster, I think. There it is. I want to make that 1 into a 0. Well, that's in the x column, so we can think of eliminating the x's. What would we do to eliminate the x's in that system of equations? I would want to have negative 3x in the bottom equation to go along with the positive 3x in the top equation. So if I multiply row 2 by negative 3 and add it to row 1, that'll get me a 0, 0x, if you want to think of it that way. I'm going to use row 1 to accomplish this, but I'm not going to change row 1. It's going to stay exactly like it is. I am going to replace row 2, because that's where I want the 0 to be, is in row 2. So I'm going to multiply negative 3 times row 2 and add to row 1 and put the result into row 2. Well, let's see what happens when we do that. I'm going to have negative 3 times what's in row 2. So that's negative 3 times 1 is 3, plus what's in row 1. Negative 3 plus 3, that's 0. We knew that. We planned it that way. I have to do the same thing for the whole rest of the row, though. Negative 3 times negative 1 is positive 3, plus negative 2, sounds like positive 1 to me. And make sure you do the row of constants as well. I have negative 3 times positive 3 is negative 9 plus 4. Negative 9 plus 4 is negative 5. Well, you know how we said each row of the matrix represents an equation? Look what that bottom row says now. It says 0x plus 1y equals negative 5. It says y equals negative 5. Oh, well, we found y. That's good news. Now all we need is x. Now I'm going to use the top row to find a value for x. So 3, I don't know x yet, minus 2 times, I do know y, that's negative 5, equals 4, which means, let's see, negative 2 times negative 5 is positive 10. I'm going to subtract that both sides. So now I have 3x equals negative 6. Divide by 3, and I get x equals negative 2. So I have the solution to my system of equations. X is negative 2, and y is negative 5. Now, is that better than elimination? Probably not for a 2 by 2 system of equations. I probably would have been done with elimination 5 minutes ago. But for bigger systems of equations, say 3 equations with 3 variables, it is pretty convenient.